Hello and welcome. It's been brought to my attention that I didn't do a super great job of explaining the following exercise's solution. So we're going to take a look at it again. For all m greater than 0, we are trying to find that there exists an n greater than 0 such that the following is true. n squared plus 6 is going to be less than m times, and of course I've already run out of room, n cubed minus 5n. Now, the very first thing that we want to do during our scrap work is we're going to factor out that n cubed on the right-hand side. So this side stays as it is, and we're going to get a factored form on the other side that looks something like this. Oops. There we go. Now, the point of this is so that we can realize that we have this really lovely term here, and we need to find something we need to find a value of n that will turn this term into being greater than 1/2 so that we can replace it with 1/2. The name of the game with these max problems is if A is less than B and B is less than C, then A is less than C. That's sort of what we're going for. So we want to try and find an intermediary value that's going to be right. Why is this not writing? That writes. That's not writing. Okay, we want to find an intermediary value that's got to go right here so that we're going to be able to prove in that intermediary value being B that it's going to be less than the original A and greater than the original C. So here's A and here's C. We're trying to find B right now. That's what's happening. So when we look at 5 over n squared, what we're actually trying to find is something that will definitely be less than 1/2, which will result in 1 minus 5 over n squared being greater than 1/2. That's what we're trying to get to here. So, pardon me, we can do this a couple of different ways, but one of the easiest ways is just to guess and check. Like if I just put if n equals 1, we're going to get 5 over 1, which isn't going to be good. But if I say n equals 2, we're going to get 5 over 4, and that's not going to be good. If we do n equals 3, we're going to get 5 over 9, which is closer, but 5 over 9 is still not less than 1/2. I'll just 5 over 9, 5 over 4, 5 over 1. Here we're going to do 5, n equals 4, and we end up with 5/16, and that is indeed less than 1/2. Pardon me. So when n is greater than 4, I'll just say, instead of saying if, I'm going to say, instead of saying when, I'm going to say if n is greater than 4, then 5 over n squared is less than 1 over 1/2. And what does that actually mean for us? Well, that means that the following will be true. N cubed 1 minus 1/2. That's a silly way to write it. I can just put the half right here. Is going to be strictly less than the original statement that looked like this. And we can tell that that's true because we're basically replacing this 5/16 here and here when n is greater than 4, and it's just going to keep getting smaller and smaller and smaller, meaning that we're going to get further and further away from that half, closer and closer to the value of 1. So we've now found an intermediary value to be our B. So what color did I do that in? Purple. So B in this proof is going to end up being m n cubed, we'll just do it like this, over 2. I can get rid of those brackets if I'm going to put it all over 2. Okay, so we have found a B value here. Now, in order to ensure that this B value is going to be less than our original A value, don't forget what that was, we'll highlight it. Here's our A, here's our B. Actually, instead of highlighting that as our C, let's just highlight the unfactored form to make our lives easier. And then this is our, there we go. So in order for us to actually be able to say that, like to use this fact here, well, we already know that B is definitely less than C because that's what we just saw. But now we have to make sure that A is going to be less than B. So in order to do that, we have to take a look at A, which is this, and make it less than B, which is this. And we have to figure out what would our bound need to be of n for this to be true. So what I'll do is I'll divide both sides by n cubed. Nope. I will multiply both sides by 2. Let's start with that. Multiply both sides by 2. There we go. And the name of the game here is going to be to isolate that n value so that we can sort of figure out what is going on. So if we know that n is definitely going to be greater than 4, thanks to the fact that we just determined for b less than c, we can use that substitute there. And then we can say, let's see here. Let's divide both sides by n squared. N squared less than n, n squared. Oh, that's so weird. I don't know what I just did there. Sorry, in my own little world a little bit. So we'll end up with 2 plus 12 over n squared less than mn. Let's take this and move it over to the other side. 2 less than mn minus 12 over n squared. Let's see if we can get everything over the same denominator here. So cross multiply that. Mn cubed minus 12 over n squared. Is that how you do that? 2 less than m n minus 12 move the 12 back over, and something went wrong. And I really have to use the bathroom. So let's just take a pause. Can't focus while I have to use the bathroom. All right, so let's start with our inequality where we're going to try and prove that A is less than B now. So that's n squared plus 6. Let's start with our inequality where we can now prove the other side of the highlighted green there, where A is going to be less than B. So we're going to start with n squared plus 6. It needs to be strictly less than n cubed over 2. And what we're going to need to do is we're going to need to make sure that we bind our left-hand side with a sufficiently large value of n as well now. So to handle this step, we start with our inequality, and the first thing we're going to do is we're going to isolate the cubic term. So basically, we want to make sure that we can compare our powers of n. First thing we can do is divide both sides by n cubed. So that'll be like adding an n cubed division here and adding an n cubed division there. So what are we going to actually end up with then? It'll end up looking something like this: n squared plus 6 over n cubed less than m over 2. So now let's just simplify our left-hand side. Let's just break it down a little bit to make it a little bit easier for us to look at, like this. M over 2. So what we see here is something that's actually kind of complicated, right? This is quite a complicated scenario for us to try to determine how to calculate it. But the good news is that there's a way for us to simplify this. But what it's going to actually involve is that's going back to that original selection of n greater than 4, because it's this side that's causing us all these problems right now, right? When we had to divide, we had to multiply the 2, we'd have to multiply the 2 across and divide out the n cubed, and there's all these things that we were doing to try to make this work. So what we notice is that maybe that n greater than 4 value isn't a stellar choice. It could work, but the math gets really complicated. However, notice for a second that if we look all the way back up at our original a value, n squared plus 6, we can see that n squared plus 6 will be less than 2n squared if 6 is greater than n. And since we figured out that n has to be at least greater than 4, why don't we go ahead and try that instead? So what I was doing before is not wrong. I don't want anybody to think it was wrong. I'm trying to sort of show some intuition here behind why we might not want to use the first value that we find, especially if we find that we're getting a little bit stuck because the arithmetic starts to get messy. I am not somebody who wants to do messy arithmetic, so I'm going to not do messy arithmetic. So we're going to pick, pardon me, that n is going to be greater than 6. We know that this also will hold true. We can write it over here again, just as we did the other options. 5 over 36 is, of course, still going to be less than a half over there as well. Okay. So now let's So notice what else this means. This means that we sort of end up with another intermediary that we're going to call a prime, just because I didn't otherwise label it, unfortunately. So what we can do is say that if n is greater than 6, then we know that n squared plus 6 is strictly less than 2n squared. That's our rounding up trick there. And so here was our original a, and this is our new a prime. So now what we're going to try to say is if a is strictly less than a prime, which we've already proven, and b is less than c, which we've already proven, if we can fill in this gap between a prime and b, we will be able to imply that a is less than c. So we have to be able to prove that a prime is going to be less than b in order for us to finish off this is just the scrap work really, but finish off determining if we picked good values here. So our A prime is going to be 2n squared, and our B is mn cubed over 2. So armed with this information, let's see if we can solve for n and find an end bound that will make this true. Let's go ahead and divide both sides by n squared so that we end up with 2 less than mn over 2. And let's also multiply both sides by 2 so that we'll have 4 less than mn. And then let's divide both sides by m, and we will end up with n being greater than 4 over m. So as long as we pick a value that is a maximum between, where's my pink highlighter, a maximum between n over 6, n greater than 6 and n greater than 4 over m, we will be able to say that A is less than A prime, which was less than B, which was less than C. And so then A is less than C. We now have all the information we need, albeit somewhat messily up here, to be able to write our official proof. So let's go ahead and start that. Now, the first thing I usually like to do is write out the statement again. So for all m greater than 0, there exists an n greater than 0, such that n squared plus 6 is less than m times, oh, I did it again. Move that over and get this out of the way. N cubed plus 5n minus 5n. Okay, so when we want to write the proof officially, the first thing we're going to do is we're going to roll back our rough work. So the very first thing that we did in our rough work is we have to sort of write down our n value. And once we've written down our n value, we can start by proving why each of these statements is true, sort of back up the chain. There we go. So let's start here by saying let n, because all we have to do, last reminder here, is prove that there exists an n. So let's do it. Let's pick an n. And our n value is going to be the maximum between the two values that we found, because we have to make sure that we hit both marks. We have to be bigger than both, right? N has to be bigger than both 4 over m and 6. So if 6 is bigger, then that means it's bigger than 4 over m. And if 4 over m is bigger, then that means it'll be bigger than 6. And we're going to make sure that we say that it's bigger than, the max is going to be equal to one of those two plus 1. And we add that plus 1 in there because then we can say that we can observe, if I put the O in, observe that n is strictly greater than this maximum. And that's the fact that we want to be able to use, which is why we add that plus 1 in there. It's a little bit formulaic of us to sort of set that rule, but for these types of proofs, that's kind of what you're looking to do. Okay, so then step 3, what do we actually want to do knowing that fact? Well, let's take a look. Let's remind ourselves that if we can show that n squared plus 6 is less than some intermediary value, which is less than, we're going to end up with 2 of them, but let's pretend for a second, some kind of question mark happens in here, which is less than mn cubed minus 5n, we prove the original statement. So that's the name of the game here. And the very first thing we want to do is get this original statement into a factored out form that works for us. So factor form is going to be n squared plus 6 is less than m. And we're going to take out that n cubed again. And we can say 1 minus 5 over n squared. And now that we have this form, knowing what we know about n, we can say that we know that n is greater than 6, right? From 1, n is greater than 6. Therefore, 5 over n squared is going to be less than a half. Yeah, we can see that it's going to be less than a half. So what does that allow us to do? That allows us to say that, therefore, it follows that m n cubed over 2 is going to be less than that original statement up there. I'm just going to actually highlight, copy, paste it over. Just because I'm such a big writer here, I'm running out of room. There we go. I'll just sneak it right in there. So that's what we can say, right? We can say that that's true because we know that 5 over n squared is strictly less than a half. So we can say that when we take 1 off of that, we're going to end up with the difference here being greater than a half. And so this side is going to, this whole thing will be greater than this whole thing. So that's great. The other thing we want to be able to say is from 1, n is greater than 4 over m. So actually, even before we say that, we will say from 1, n being greater than 6 means n squared plus 6, that's our right-hand side, is going to be less than n squared plus n squared, because n is already going to be greater than 6, meaning that that n squared is going to be 36 or bigger, definitely bigger than 6. So now we know that n squared plus 6 is strictly less than 2n squared. So now we're in that same position we were in before. Let's prove n 2n squared is less than mn cubed over 2. And as long as we can prove this statement is true, we'll be able to successfully say that this side we know is less than this side by step 5. This number is less than this number by step 6. And then by step 7, this is less than this. Therefore, this will be less than this. Map all those out for you. Okay, so how can we do this proof? Well, we're just going to do what we did before. We're going to isolate n to prove that we picked an n value where this is going to work. So let's do this proof. We're going to multiply both sides. Multiply by 2 on both sides. So we'll end up with 4n squared over mn cubed. We can divide by n squared on both sides. So that will end up with 4 over m times n. And then in step 10, we can divide, before I didn't even write the word divide. I'll be the same. Divide both sides by m. We'll end up with 4 over m is less than n, which by our original step 1, we know to be true. Okay, so then in our final step here, we can now say, let's bring it all together. Now, in theory, you could just number these in your formal proof, but I'm going to be a little bit more explicit just so that we can actually really understand how all of these pieces connect. So from, this is our step 1, from max of, 6 and 4 over m. We'll say from 1, max is greater than, n is greater than that. And by combining, what numbers did we say they were? 5, 6, and 10. 5, 6, and 10. We started with n squared plus 6, and we showed how that was going to be less than 2n squared, which we showed was less than mn cubed over 2, which we showed was strictly less than m times n cubed minus 5n, and then that's our proof. So just as a final hurrah, let's just confirm how we did each of these. So this one we proved using that round up trick because we knew that n was going to be at least as big as 6, making n squared big enough. Then we did this one here. Well, actually, the next one we did, the first one we did was this one here, which we did by saying that we knew given our n value being greater than 6, we knew that this side with the half would be smaller than the other side. And then once we proved both of those, so that was 5, and this one was 6. And then once we proved both of those, in order to bridge the gap right here, we just solved for n, and we showed that we're definitely going to end up with an n value that will be greater than the result, which was 4 over m. And so we've now created this connection all the way across, such that A is less than A prime, which is less than B, which is less than C. Therefore, A is less than C. And we did it. We proved the whole thing. All right. I know that's a doozy of a proof, but I hope I was able to break it down for you at least a little bit. And as always, let me know if you have any questions. Thanks, everyone, and I'll see you in the next one.